All right, sounds good. Okay, so my name is Victoria. My mentor, Dr. Sun from California Polytechnic University, is unable to join me today, so I'll be presenting this on my own. So first of all, good morning. It's an honor to speak here today. And my paper is titled Lyrically Yours, a mobile application for automated music therapy through lyric analysis, utilizing natural language processing and machine learning. So the goal of this project is to leverage natural language processing techniques and machine learning to provide personalized song recommendations, but based on not only just emotional values, but also narrative elements. And to do this, I made a music recommendation system that basically analyzes lyrics and the user's search query and matches the two. And it's a system that effectively takes into account lyrics as well as the music elements. So first of all, my system uses Firebase, which is made by Google. It is a tool, a website for cloud storage, and it's providing me with effective data storage and retrieval. It stores information both about the users and also about the songs. And the Flutter framework facilitated the development of a user-friendly mobile application interface. And basically, this framework allows me to write one set of code that works for both iOS devices and Android devices, which, as some of you guys may know, is difficult since those two different platforms require different things. So a lot of times you can only write code for one platform but not the other, but Flutter does a great job of letting you work with both. So the accuracies of I tried out different machine learning algorithms, and their respective accuracies supported the use of random forest for emotional classification, and I was able to achieve an accuracy of 89%. And basically, through this interdisciplinary approach, my project endeavors to offer an accessible and automated music therapy experience. All right. So first of all, I would like to share the origin of my project. It comes from everyday observations of people, including myself, who listens to music as a way to de-stress and get through hardships. And relatable lyrics really play a role in being a healthy coping mechanism for many. And so I did some background research into this, and I found these papers that says basically lyrics are an accessible and accurate indicator in mood estimation. There's a study done in 1994 with 42 college participants, and they actually found that lyrics had a larger emotional impact than the music itself a week after the experiment. I think a lot of us really place the importance of songs onto the musical elements, such as, valence, speed, tempo, etc. And we don't give enough credit to the words that are in the songs. And also, this, according to a research paper in 2014, the application in therapy of using lyrical analysis, it serves a similar purpose to poetry therapy, but it's in a form that adolescents are much more willing to accept, and it's much easier to build rapport between the therapist and their patients. Because obviously, poetry therapy is a little difficult to understand, especially for young people, but music is much more accessible, it's fun, so these patients have a lot of an easier time accessing this material. However, mainstream song recommendations are still centered on the mood analysis of songs, not lyrics. So take Spotify, for example. Spotify's Matrix, they have a very extravagant, very complicated model, and they do a pretty decent job at recommending music, but they don't really take lyrics into account. It's not until recently that they even included a lyrics feature on their application. And for example, also Pandora, which is also a leading streaming platform, at least here in the United States. They have a very complicated algorithm to analyze songs, but they are very much confined to a few classification categories. And in doing so, they are kind of abandoning the narrative behind each song, which has way more nuance than a few categories or even 50 categories. And also, here's this paper from 2021 that states the application of this field in computer science is still relatively unexplored. There are significant advances that have been made between music and perceived emotional impact already, but there has been significantly less focus on lyrical analysis. And so, to bridge this gap with the guidance of my mentor, Dr. Sun, from Cal Poly Pomona here in California, I started to try automating the process of lyrical analysis. All right. So for methodology, I knew earlier on that I wanted to develop a mobile application for this. And there are various reasons, but most glaringly, mobile applications with the number of people who own phones in this day and age have become the most accessible form of technology. And my point in creating this whole project is to make lyrical analysis more accessible. So songs are stored with their keywords extracted through a natural language processing algorithm that I will introduce and expand on later on. A machine learning model is trained on a data set of statements with their emotional attributes, and this model will be the one that will categorize the songs into emotional categories. Now, the reason that I still have emotional categories is because matching keywords are effective. However, each keyword can represent and be present in a variety of emotions, right? So it's extremely important to make sure that the recommended songs are not only matched to the user query in terms of keywords, but their overall emotion and mood also matches. And that's why I have this two-layer approach of using both natural language processing and machine learning. And so when the user enters a search query, what happens is that the query will be analyzed using the same two algorithms. The machine learning model will assign it an emotion, and the natural language processing algorithm will identify its keywords. And these keywords are compared against the ones of songs in the corresponding emotional category, and matches will be displayed to the user in terms of descending match. So by automating this process, my approach enhances the efficiency and inclusivity of this division of therapy, and I hope to simplify the process of getting appropriate mental health attention. And so here are some screenshots that kind of demonstrate how the process works. As I mentioned before, my data are stored in Firebase like so. So under each emotion, I have each song, and then under each song, I have the keywords here. And this is the UI of my application. So that the user will input search queries. Here are some recent searches for an example. And then after they input the search query, the songs will displayed by descending match. All right. So in order to kind of narrow down what kind of algorithm I wanted to use, I used a Kaggle dataset named emotions dataset for NLP. To test my models and train and test them. So I of course partitioned this data set into a training set and a testing set. The training set has 15,000 statements and the testing set has 2,000. So this data set will be used on 4 different algorithms: random forest, logistic regression, support vector machine, and decision tree. And so they will undergo training and testing using the same data set, and they will be evaluated. Here are the results of their accuracy. As you can see, they all achieved pretty decent results. But random forest does have the highest percentage of an 89%, and that's the one I decided to use. And for some context, basically what random forest is it is a bunch of decision trees. And decision trees are basically links of nodes that ask questions, and they lead to different classification results. So by having multiple decision trees, what random forest does essentially is that each decision tree will get a different set of training data. And thus, outliers are able to have less of an effect on the overall algorithm, since, instead of in a normal decision tree algorithm where an outlier is seen by the entire decision tree, in random forest, because there are multiple decision trees, an outlier is only seen by some of them. And thus, It makes it a lot easier for outliers to be tolerated, and thus random forest retained the highest accuracy. And so I would like to first identify a couple of terms before I show my results. So the recall accuracy is identifying the given emotion correctly. Precision is to not misidentify other emotions as the given emotion. F1 score is a harmonic mean that combines these two. So the accuracy that's shown here is the F1 score, which kind of is a mix that effectively represents both the recall and precision, which are both very important in this case. And here's a more complete classification report of the four. As you can see, random forest does have a better performance. Especially, I would like to highlight the emotion sadness, which given the intended usage of my project will probably be the one that is most seen. And so because its accuracy is so high across all categories, this is a very good sign for my project. But in random forest, it reaches a very impressive accuracy of 95%, which is obviously another reason that I'm utilizing this algorithm. So moving forward, I also decided to use a technique called local interpretable model agnostic explanations, abbreviated LIME. So what it does is it allows programmers and researchers to look into black box machine learning algorithms. Now, most of the time, we do not know how these models function and how they reach the conclusions that they do. But what line does basically is if you take this picture, for example, say that blue and red are the two different classifications, and the model is using this kind of irregular shape in order to make its predictions. Now, obviously, Lime cannot replicate exactly the behavior of the entire model, but what it does is say this bolded cross is where I want to see the model's performance. And it will test points that are close and along this dot, this point of interest. And by getting the classification of the neighboring areas, what it's able to do is form an estimation. And in this case, that's represented by the dotted line. And this estimation is able to kind of estimate and simulate the performance of this model that is right along the dividing line. And thus it is able to give Lime an idea of how this model is making this decision right here. And so I used it on this one statement that represents fear on two different models, logistic regression and random forest. And as you can see, both of them correctly identified this emotion as fear, which is very good. As you can see, vulnerable is the keyword that really made them, make this decision. But I would like to highlight one thing is that logistic regression highlighted the word struggle as joy, which is very interesting to me because struggle in basically no context means joy, and it does not convey the information, the emotion whatsoever. The other ones I can kind of see, but struggle was very confusing to me. And as you can see, random forest struggle was not an emotional expression of joy at all. So I wanted to find the source of mistake in terms of logistic regression. And so I looked into, excuse me, here we go. My PowerPoint got scrambled up, but I did look into the training data set. And as you can see, I put on some statements that contain the word struggle and has been assigned the emotion joy. So the first two are just misinterpretations. They do include the word struggle and they can be interpreted as joy. However, because of the nuances of the English language, they just the meaning got messed up in the middle, and I can see why they're classified as such. However, the ones that are highlighted in red, the statements do not express joy at all. These are ones that have been misclassified during the process of making the training data set. Now, with a data set that has this much information, mistakes like this are normal and they have to be accepted. However, this really just highlights how much of a superior performance random forest has because of its multiple decision trees. Instead of like being influenced by these outliers like logistic regression was, random forest really held up and was pretty much unaffected. As you can see, struggle did not play any role whatsoever. And so this again just proves that even though the performances of the models, if you look at the average here, are kind of similar, Random Forest was a lot more confident in making its decisions and it was a lot less affected by outliers. Obviously, outliers appear a lot in this kind of context because there is so much nuance within the language. So this kind of resistance to outliers proves to be extremely important in this case. So random forest remains the algorithm that I have used. All right, so moving on to my second round of testing. I did testing on the algorithms across the different emotional categories because obviously you want these to be basically consistent, at least starting out. My approach was I wanted them to be consistent. However, what I soon realized is, as you can see on the right with their F1 scores, they were far from consistent. They range from in the 90s for emotions such as sadness and love to in the 60s and 70s for surprise and joy. And at first, I thought this was probably a problem, but what I ended up realizing is that since the application's focus is on music therapy, emotions such as sadness and love will be utilized more than joy and surprise. So I acknowledged the discrepancies and I tolerated them. Also, to kind of interpret the data further, the reason that I think there is this discrepancy between the emotions is that some of these emotions are much easier to understand and also to identify and when it comes to a machine than others. For example, sadness is something that has distinct keywords. If you are crying, if you are heartbroken, and love also have very distinct keywords. There are words that are very much associated with love, and love songs are very easily identifiable. However, emotions such as joy is a lot more abstract. For example, a song that sings about joy can literally just be about a guy going on a road trip. Now that has a lot less of specific keywords that the machine can grasp onto for appropriate and accurate distinction. All right, so to talk about the natural language processing algorithm that I utilized a little bit as well. So it's called RAKE, Rapid Keyword Extraction. And basically, this is an example of how it works. So this is the example phrase. Now, I learned about this algorithm through this blog post right here, which is very useful. And so basically what it does is that it takes these words from the statement and it puts it into a table like so. And each unique candidate keywords get their key phrase count. Now, the count is basically how much each word is associated with the other, and then they get a total sum. Now, higher the sum, the more associated it is to other words, obviously. So the degree of the word is this sum right here. So higher the degree, the more associated it is with other words in the statement. And then you have the word frequency, which is how many times it appears. The degree score is the degree of the word divided by the word frequency. Now, if it appears more, if it has a higher association with other words in the same statement, this degree score will be higher. But if it has a lower frequency, it also will be higher. So degree score really is kind of taking into account both the association to other words of the keyword and also how much it appears. Now, obviously, higher the degree score, the better. That means the more associated each presence of this keyword is to all the other words in the statement, and thus, obviously, that word is more important. So moving forward, here is an example of a sample lyric snippet and also the keywords that have been extracted from it. I have bolded the ones that I think would really allow my algorithm to make a decision and to give the right words. As you can see, some of these really do capture the essence of what this song is trying to express. And if the user's query contains any of these words, they will be, like, this song will be displayed as a match. Yeah, and here are the degrees, scores of the different words. Also, just as a side note, I implemented the RIG algorithm using the NLTK Python library, and also I implemented the machine learning models as part of the Python library as well. So to give credit to those libraries, which have been very useful throughout this entire process. So in conclusion, since the English language has a high level nuance and variety of potential meanings, the ability to handle anomalies was extremely important, and that is one of the reasons that I decided to utilize the algorithm random forest, along with its just superior accuracy. So practically speaking, this project with limited functionalities has already been published on Google Play Store and Apple App Store, extending its accessibility to the general public. Now, this version is kind of a debugging/testing version, and it does have some connectivity issues, which I am now fixing. And I do plan on updating it with new versions as they become finalized. The ultimate aim for my project is to serve as an effective and really accessible tool, because music therapy, especially this very niche subdivision of it, is not something that most people have readily access to. And furthermore, in the future, I do hope to explore methodologies that can gain insights into the context of lyrics, because certain stories and context can be told without the use of explicit keywords. The same story, the same narrative can be told using two different sets of text that have zero overlap in keywords, but they will be able to convey the same meaning, and that is both the beauty of the English language and why it is so difficult to work with. So I'm always looking for models that can improve that. So if any of you know any ideas, feel free to suggest that to me. I am also looking into research that's done on poetry therapy, because those do consist of some similarities, poetry and lyrics. So if there are any approaches used in poetry therapy, I will also try to apply it in this case as well. And looking forward, I am contacting industry professionals to get their opinion on this application and this project. So right now I've been emailing certified music therapists for interviews, etc., for their opinion, and also if they have specific techniques that they use in their practices to help their patients. Like, for example, if they want to focus on one specific aspect of the lyrics context, etc. I would just love to hear what they say. And I do have interviews with them coming up, so I'm always looking forward to hearing their takes on this approach. And here are my sources, and then some pictures to go along to show this process of designing the application. Thank you, and that is it for my presentation.